Hello, joining us, we have Ascent data scientist Ashley Baldry discussing how to set up a JavaScript library for your Shiny application. Ashley specializes in the development of Shiny applications with a strong interest in HTML frameworks and UI design. Ashley is an active member of the R open source community. He's a creator, maintainer, and contributor to several Shiny packages, including Designer, Video, Howler, Shiny Title, Fomantic Plus, Shiny Semantic, shout out, and Appler, to name a few. Ashley, welcome to the stage.
Thanks very much, Micah. Cool. So I'm here to talk about upping your JavaScript game and being able to create a library in a Shiny application. For anyone, so with Shiny, it's all written in to allow you to use JavaScript within any application. So being able to add in your own JavaScript is just a match made in heaven. It really helps improve your applications. So your journey into adding JavaScript into your Shiny application will start off by going on to Stack Overflow and copying whatever code you find on there and just banging it into your application. In this case, it is making nice tooltips for your hover over tools. Then as you include more and more JavaScript into the application, you might convert it into a script and call it in using the script tag in Shiny. Alternatively, you might need to create custom inputs or custom outputs, and then you have these custom bindings that help it further improve your application. But then after you've done all that and you have even more JavaScript and it's starting to become unmanageable, what's the next step? So I came across this issue with the Designer package, as mentioned. For anyone who isn't aware, Designer is a R package that is a code-free solution to create the UI of Shiny apps. It contains pretty much every UI component within Shiny and BS4, most of the ones in BS4 Dash. And you can basically drag and drop any element that you want within there and copy the code into your RStudio file, or you can share with colleagues and friends. This is how my JavaScript looked at the start of the initial release. There are 4 files here. One of them is the canvas page input, which was a custom input binding. And then I had a couple of files with the setup and utility functions. All 3 of those were about 50 lines long. And then there's other one, which is the create element JS file. This is about 650 lines. And this contained basically all the JavaScript I needed to generate the different components. The first release was just the Shiny components, but as part of the second release, it was including the BS4 Dash, and therefore this file was getting bigger and bigger and getting very unmaintainable, and it was making it hard for me to know what I was actually editing. And there was also, because most of the creation was similar for all components, there was a lot of duplicated code. So trying to work out what I need to do next, and that was to create a JavaScript library. So to set up your JavaScript library, you choose an IDE. With R, it's pretty much RStudio, and now more people are starting to use VS Code or other ones. For JavaScript, there are so many out there, and people write listicles about the top ones. I personally like VS Code. It allows, with all the extensions involved, and tools available in it, including auto linting, which is a godsend. I would personally recommend that one. So then you create within your R project, a directory for where your JavaScript code is going to hold. The standard name for it is src.js, where the src stands for source. Did not know that before this. And then if you're creating it as part of an R package, don't forget to add this to R building nor, so it avoids bloating up the package. Then install Node.js. This is the runtime for JavaScript, and it allows you to run JavaScript without having to open up your browser and run it in the JavaScript console when you use the inspect tool. Inside of it, there's a load of extra tools such as npm, which is a package manager and allows you to install all the dependencies for JavaScript code. And then once it's all set up, you can open the srcjs directory in your IDE of choice, and then in the console run npm init. This will help initialize your project. So I've got a quick example of how it runs in here. Yeah, one of the other benefits is being able to really customize VS Code. With npm init, it will ask you a few questions to set up your package library structure, such as the name, version, description, and few other details. It's almost like creating your description file for an R package. There are a few other questions that it asks that you can skip. And then once it's all confirmed, it'll give you an example and add it into this file called package.json. This file is basically your description file and looks like it's a JSON file and contains most of the same fields. A couple of the extra ones, fields that are not normal to R, are the main, which is the point where everything that is exported in your JavaScript library should sit. And then scripts. Scripts allow you to run chunks of code without having to, by just using the command npm. So in this case, there's one that's auto added in here for test. So you say npm run test, and at the moment, it will just give you saying that there is an error, that no testing has been implemented. So now you've got the very basic setup. Now you want to install the dependencies. As mentioned, Node includes a package manager called npm. This works very similar to renv, where you use npm install package, and it will install the package and store it all in a lock file. So you can easily share the versioning across different contributors. For any project with Shiny, include Shiny and jQuery. Shiny uses jQuery a lot, and it helps with creating JavaScript within your own code. To do that, as mentioned, use npm install. And because Shiny's in a GitHub repository, you just prefix it with GitHub, and it will point and it will look for the package JSON file in the GitHub repository. Shiny have very kindly put it at the top level, so it makes it easy to install. Then with jQuery, we get the exact version that's used in Shiny, which is 3.5.14. The types means it's a TypeScript library. It doesn't affect development, but is required for the installation. You also can install project-specific dependencies in here. For my project, I've used sortable.js a lot, so I included it in here so that could reach the function. This is a very important note. Include Node modules in your git ignore. The Node modules folder is where all the packages get installed. And by default, because you're in an R project, it will not include this in your git ignore. I've done this on 2 projects, and both times I've forgotten, and it will upload several hundred to thousands of files into your Git, and it's just a pain to get rid of. So after you've installed them, you can see here, and the package JSON has got that bit bigger and includes the dependencies. This is basically the imports of your R package. You can see there that there's also the Node modules folder with all the dependencies installed in there. Next, I want to make sure that all my code I can bring all my code from where it currently is in the inst folder into the JavaScript. And by that, we bundle up code. This is an example of a bundling script. And I've put all my code into a single file called index.js. The reason for bundling is so that I can have multiple files, and then it can point it all into the single entry point and then chuck it back into my Shiny external files without any issue. So you can see here it goes to the app www and a minified file. Minified files make it reduce the size of your JavaScript. And whilst it's not particularly useful for when it's only like 20 or so lines, once you start having a large amount of JavaScript in your app, it's really beneficial as it reduces it down to variables to single letters, but still working exactly the same method. And it helps reduce the amount of time it takes for applications to load. And again, we use install save dev. The reason for save dev is so that it's a dependency and it doesn't require it when trying to compile the library. This gets added. So this gets added to the dev dependencies in your package JSON file. And this is like the suggests, but the suggests only get used for development purposes. You can also see here that I've included that build script into the build.js, and the index file has all my JavaScript code in. I want to quickly plug in linting. Before starting any project, I feel that linting is required everywhere. It helps with your code quality and consistency. One thing I learned from this project is that you no longer need semicolons at the end of your JavaScript commands, which is really nice. And again, use it by using save dev and installing the ESLint. There are loads of linters out there and loads of build packages. The ES family seem to be the quickest at performing what they do, so that's what I've chosen. There's an extension in VS Code as well that applies these standards and automates it. Sometimes if you just click save, it'll just do it all for you, which is a time saver as well. And you can add your own rules into the specific lintrc YAML. I have a weird naming convention, so I like adding that into these sort of files. So now, after installing ESLint, you can see it's in there in the dependencies and the YAML file. One thing I forgot to explain in the build step is that in the scripts, there's a new field, which is the build. This node, build.js, means it will, by just using npm build, it will run that build.js script and bundle it automatically for me just by writing that command in the JavaScript console, or the terminal, sorry. So the package is pretty much set up and it will compile and it does what I need it to, but the index.js file is very messy still, and now it's all in one file, it's even less maintainable. Two ways around to fix this is communicating between files. Here, with R, you can put a function in one file in an R package and it's available everywhere else in the same package. With JavaScript, it does not work like this. It works in a modular fashion. That means only the what is imported and it's created in that file are available in that file. So if you've ever used the box package and that's available in the Rhino infrastructure, you basically you have to explicitly import packages or packages, objects, and any functions explicitly before use. So in the example on the right, I have two files, a component and a button. To export the component, I have to add the word export before it. And at the top of the button script, you use import object from and the file location it's from. Then it's all available to you. If you want to use these import calls, you have to add in this extra field in the import, the package JSON, and it's just saying it's a module. It's needed since the newest version of JavaScript. The other thing that has been really useful is this class inheritance. So in the example, I did have this component and button. There are loads of buttons available in the designer application, and a lot of them share methods that are that I can reuse easily. This helps basically help me reduce code. Where R is functional, it JavaScript is more object orientated, so it's kind of similar to how the R6 package works. The constructor helps you initialize the object, and then you can add in either parameters or functions, and by default it will include these in the inherited classes, but you can overwrite them. So in this case, if I wanted to create a component, the create component was used consistently across about 4 or 5 different components, and so I included that. But the HTML for each component is different, so that needs to be added in every time I create a new component. And here's some more information about what I wrote. So other functions that were included in the component were generating random IDs, validating the CSS of like the height and width of components and other bits. But yeah, there are extra methods that were needed for things like creating a new tab, or if it was a dynamic input, then it needed more things included in the class for it to work. Once I had split all these out into different components and different page types, and just sorting out the couple of custom inputs that I had in there, the library kind of looks a lot more fleshed out. There's like specific folder for the different pages, a specific folder for all the different components. It would hide a lot of this if I expanded it. And you can now see that my index file has at the start of it some initialization functions and the custom bindings. This is all that I needed for exporting and bundling into the single Minify file. And as you can see, it's only 25 lines long, so it's very easy to know what's being brought into the application. Another thing to really go on about is unit testing. In R, there's basically test that and now Shiny test too. In JavaScript, there are so many different frameworks available, and you can choose the flavor that you like. I was recommended to use Jest, as it has a very similar structure to test that, in that you have all the individual tests saying expect something to something. If you want to look at other test packages, there's Mocha.js, Chai.js, and Cypress. With Jest, I can add test into a test subdirectory with the 2 underscores before and after, and then you suffix any test with .test.js. And again, installing as a development dependency as Jest. This Babel plugin allows you to test with the module structure. So here's an example test. As you can see, I'm just using the button again and having to import the button object from the button file to test. And as you can see, it just says test. And the simple function here is just saying expecting the button HTML to be what I created the button HTML to be. You can make these a lot more complex than this, but it's nice to have a basic example. And the other thing that you can do is update your test script. Here I have the test to now be Jest. This is almost like a command line call, and by running npm run test in the console, it will run through all the tests that I created in my package. In here, most of them are checking whether the file exists and whether the structure is correct. You can see it gives you a nice pass fail on all the different tests that are available. Another benefit is that you can add this into your continuous integration, and you can include it as part of your GitHub Actions. And it's so small that I can fit it on a single slide. In the GitHub Actions, you can it already has npm installed in it, and Node, so you don't have to do any pre-installation. You just point it to where your JavaScript library sits, and you can run the npm install to install all dependencies, and then run npm run test to make sure it runs the jest or whatever you would like to use for your testing. And this is an example of what it looks like in the output of JavaScript. The whole process takes less than a minute, so it's very responsive if you've got quick tests. So after all of that, this is how the final structure of my JavaScript library looks. You have the package JSON, all the files that are required, and all the necessary development dependencies that you have included, as you would with any R package or project. You can see here, this is what the current folder structure of the external dependencies of my designer application look like. And there's just this one minified JavaScript file. Yeah, and there you go.
Great, Ashley. Thank you so much for presenting. You very tactfully posed the question of, or maybe not a question, but the statement of VS Code versus RStudio, and that kind of kickstarted some discussion in the chat. But like you said earlier, I think you mentioned something about both have good uses for particular cases, and there are other options as well. And in this case, as someone who's used both, presumably, for the RStudio fans who primarily use RStudio in the audience, is there anything different for them? Like any reasons why they would choose VS Code over RStudio, especially with JavaScript?
So I actually use RStudio for pretty much all my R stuff, and then every other language use VS Code because it's just that dynamic. But I think I want to try more VS Code because with the Shiny applications, you don't need all the tabs in there, and then the Git integration of VS Code is quite nice as well. Just whatever you feel more comfortable with.
Mm-hmm. Yeah, it seems to be the case, and Eric in the chat also posted a good comment on using what's good for you, what you like, and what's best for the project. So we have an additional question here. What are the differences between Posit's Shiny UI editor and the designer package?
I think, okay, so with Shiny UI editor, it allows you to update your UI.r file, and it will take in the UI file from a existing R session and basically use that as a existing template. Designer does not have that. I think there's a few more components in Designer, and I think probably the biggest difference is just the UI and UX of the two apps. I think just use whatever you're more comfortable with and prefer.
Yeah. And from Stephen, we have a question. How did you get the JS dependencies down to a single minified JavaScript file?
So that is all down to the build step. So with everything pointing to that index.js file, and then you have the build, it will bring in all the imported functions at the top of the script of that minified file, and then slowly, and then at the bottom of it, it will basically use that last index to make everything available in a web page or Shiny app.
Great. And we have time for maybe one last question from Yaneth. For an R user who's coming into the JavaScript language, what are some of the key features to learn to lay a solid foundation?
Okay, I'm just going to plug Code Academy. I basically went through a long course of learning HTML, CSS, and JavaScript, and it went through all the basic steps of how to add new JavaScript functionality. And I would also recommend just exploring the console and just using document dot and just get element and then see what you can do to manipulate stuff. And that's probably the first step of being able to change anything in a web page.
Great. And I guess we have time to sneak in one last question from Libby. How much of JavaScript in general did you know before doing all of this?
Very little. I pretty much, for the library structure, I looked at the RStudio Shiny repo. I was like, oh, they've got this file. I should use this. And learning by copying is definitely the way to go with this sort of thing.
Great. Well, thank you, Ashley, so much for presenting. If you have any questions for Ashley, be sure to reach out. And Ashley, if you don't mind, if anyone reaches out on Slack or on the chat, feel free to stick around.
Yeah, will do. Thanks very much.